What's up, everybody? It's Miss Wesley, and here we are for Parabolas Day 4. We are in Conics Packet 1, page 37, looking at the bottom. We're going to backtrack and try a couple problems that we didn't get to in previous lessons. And we're going to warm up with these classifying questions 7 through 12. You've caught me as I've cracked open a nice mini Dr. Pepper. Very refreshing. And before we start, I have a question for all of you, and the question is, why can't banks keep a secret very well? Because they have too many tellers. Now let's look at number 7. State whether the graph is a circle, parabola, ellipse, hyperbola. Think of your general form here and the two most influential terms in terms of classifying conic section. And those are going to be the two squared terms, the x squared term and the y squared term. I claim that just knowing what A is in general form and what C is in general form can get you all these solutions. So can you try these on your own? Pause the video and just see if you could look at those coefficients and decide on which conic section is being represented, and then come back and join us. We'll check your answers. Let's look at 7. I see A is 1 and C is 4. When A and C are same sign but different numbers, you know it's going to be an ellipse. I wouldn't have picked circle. Maybe if I was skipping to number 9, where I see 2 and 2 for A and C, right? 2x squared, 2y squared. That's a good candidate for being a circle, the same exact coefficient. But this one's different coefficient, same sign. Are these the same coefficient in number 8, a 1 and a 1? I guess I won't fall into that trap because I know that any version of a general form has all of the terms on one side or the other. So whether you subtract the x over to this side or subtract all these terms over to the left side, your x and y are going to have opposite signs here. So let's make this one a hyperbola for A and C being opposite signs. The one underneath it, well, I like this one. Dead giveaway, it's like the ones we've been doing lately. Your x squared term is missing. You've only got one squared term present, so it's got to be a parabola. And then 11, back to an ellipse, right? 4 and 7 in general form, same sign, different numbers. And 12 kind of reminds me of number 8. Either way you slice it, getting everything on one side is going to leave you with x and y squared terms of different signs. So how about hyperbola again? All right. The next page you already tried. I was thinking we look at one of these just for some strategy. So you probably have already tried number 1 on this page, but can you walk me through how you did it here? So you've got x squared and you want this to get into standard form. So when you tried this one, you probably moved anything that didn't have anything to do with x to the left-hand side, and I'm going to leave the x stuff on the right. You really could have flip-flopped the sides too, but for now I'll leave it like this. This is one, we haven't seen a lot of these where you have a coefficient sitting in front of your squared term, so I wanted to just make sure that we're solid on this case as well. We definitely want to factor things, so I'll go y minus 5, and I'll leave some space because I'm probably going to add something to it. On the other side, we can't complete the square until that -3 comes out. So you probably did that when you tried this problem. Then you want to add something to both sides that'll complete the square here. I know this -3 has to move. I'm going to wait another step before I move it. I'm going to add the one here that's needed to complete the square. Over on the other side, I should have switched colors, I'll just underline it. Over on the other side, I wasn't really just adding a 1, I was subtracting 3 from this side, because -3 times 1, so a -3 on that side. Leaves you with a y minus 8 and a -3, and this thing factored, so you got something like this. Then you want to divide over. In our standard form, you're going to leave the coefficient in front of the non-squared variable. So let's divide both sides by -3, and you get 4p is -1/3. Y minus 8, and then x plus 1 squared. So that should help a little bit in getting all of this stuff when you at least have standard form. I want to talk about getting p too. So 4p always equals the number sitting out front here. 4p is -1/3. What'd you get for p? We got to multiply by 4. So p is going to equal, or divide by 4. So how about negative, we'll say 1/12. And you can check this with the key. I'll let you fill in all the rest of the answers and check your answers there for the graph too. Okay, main event. Can you scroll all the way? We're actually going to solve these. Scroll all the way. Can I virtually shake your hand right now? Because you have now made it to page 39 of the packet. This has to be the most lengthy packet that we've covered all year this year in pre-calc, and we're at the end of it. So I'd like you to pause the video and take your own look at 6 through 9. Can you try those first and then tune back in? Let's see how we compare on some of these. You do not have to make a sketch, but we will make a sketch, I guess, to get our bearings with the problem. So I might use this little line helper. And it says the vertex is at -1, 6. I got to give myself room for this. So -1, 6 is going to be the vertex, and we'll put that up here. -1, 6. Say this is up at 6, and that's over at -1. What am I not using the pen here for? Okay, so -1. The axis of symmetry is horizontal. That's good information because now we know y is the squared variable here. So it's going to be a y minus k, quantity squared of 4p and an x minus h. And in we do know the vertex, right? -1, 6. So y minus 6 squared, x minus -1 squared, so plus 1, and not squared on that side. 4p is going to go here, and we've got to get p. So let's see. We know this thing opens horizontally, and we know the parabola passes through the point way over here at -9, 2. So it's probably going to be a negative p value. Let's find that out for sure. By using the point that the parabola goes through. This is a sample x and y that should satisfy the equation of the parabola, so we should be allowed to just momentarily plug in 9 for all the x's and 2 for all the y's. So 2 minus 6 squared equals 4p times -9 plus 1. Okay, so -4 squared is 16 equals 4p times -8. You get 16 is -32p, and p is -1/2. So that was the missing link, and we were lucky to have that extra point to be able to do a plug-in. Now we can just plug that value back in for p. So we had y minus 6 squared, 4p, so 4 times -1/2, and then x plus 1. And we'll call it a day on that question. Move on to, okay, I don't really know what that does. Circle that answer and move down to number 7. Okay, axis of symmetry, x equals 2. Focus is at 2, -6. So we have axis of symmetry at x equals 2. The focus has to be on this line. So 2, 1, 2, 3, 4, 5, 6. Focus is down there. And p equals -2. So we know this parabola has got to either open up or down, and I'm leaning towards down since p is a negative value. The vertex needs to be 2 units up from there. We'll put the vertex up here, 2 units above that focus at 2, -4. So all this is really good information to know. We have x being squared here because this thing opens down. And we have our coordinates of our vertex, so x minus 2 quantity squared. And then we'll look at the y's. 4p, so 4 times -2. Why don't we just fill in a -8 right now? And y minus the y coordinate of the vertex. So that would be a 2. And that would not be a 2. I wonder how much of this it'll let me. Ooh, that's awesome. I just needed the end of that to go away, right? And I should have looked a little more closely at that k value. Y minus -4, aka y plus 4. And I think that looks pretty good. Let's make it purple. For standard form, circle it, and move on. Number 8, focus is at 3, 0. Length from focus to vertex is 2 units. And another one of these, the parabola has a minimum. You know, if you see that vocab word, if you see the parabola having a min or a max, it's going to open up or down with x being squared. A minimum is a low point the graph hits. So we know x is squared, and we're expecting a positive p-value. All right, let's see what we need. Focus is at 3, 0. So focus 3, 0. Length from focus to vertex is 2 units, and we know the parabola opens up, so you'd actually have to go down 2 if this is the focus, down 2 to get to the vertex so that we are opening up toward the focus. And that means p is 2, right? They gave us that in the problem. And that means the vertex, what's 2 down from 3, 0? 3, -2 should do it for a vertex. So let's go x minus 3, let's go y minus -2, so plus 2. And for p, what did we say? P was 2, so for p we'll put another 8 in there. We'll circle this one ourselves. Number 9, focus is at 2, 2, and a directrix is at x equals -2. This is the classic, the old, let's give you the focus and the directrix trick. So we'll give this one a try. Focus is at 2, 2. And directrix is x equals -2. So 2, 2 is the focus, Directrix. All right, so how is all this going to help? Oh, Directrix I'll just make solid. How is all this going to help us get the vertex and the way this thing is pointed? I bet you could look at the picture, think about the points, and tell for sure that the parabola is going to open sideways. And the vertex should be exactly equidistant between focus and directrix. If this whole distance is 4 units, then P must just be 2 units, and positive 2, right? Because we're opening to the right toward the focus. So vertex coordinates looks like they're at 0, 2. I think this is all the pieces to the puzzle. We've got what's going to be squared, y or x. We're sideways, so y minus 2 squared. 4p, so 4 times 2 is another 8, getting sick of these 8s, and then x minus 0. Really no need for those parentheses, and you have standard form. All right, time for the very last question in the entire packet. Such a momentous occasion. The parabola has a horizontal axis of symmetry, and another one of these passes through. So just one more opportunity to practice with writing your own system to be able to get the equation of a parabola. And horizontal axis of symmetry means the parabola is going to open sideways, obviously, either to the left or to the right, depending on the points. But more importantly, you have a y squared term in this general form, and there is no x squared term. A parabola has one or the other in terms of squared terms. So we can write general form of this parabola equation with no x squared term present. Let's go through point by point and see if we can plug in the coordinates for x and y and get a good system to solve this. 0, 0 should be my favorite thing to plug in for x and y. 0 for both x and y makes this term, and that term completely drop out. You get f equals 0 for your first of those 3 answers. 3, negative 2. So 3 in for the x and then negative 2 in for the y. So negative 2 squared plus dx, so d times 3, plus ey, so plus e times negative 2, I'll say negative 2e, plus f being 0, so we'll let that equal 0. And I'll just rearrange this, although it's not solvable on its own now. Once we have, maybe I'll circle it so I don't lose it. Once we have another equation in terms of 2 variables, we can solve these as a system. So negative 1, 2 gets plugged in for x and y. So y squared, 2 squared, another 4. D times negative 1, so minus d. E times 2 plus 2e. I like that. Plus 0 equals 0. So you get negative d plus 2e equaling negative 4. This, I don't think we need to reach to a calculator for this one. It is set up for elimination. You've got the e's with exact additive inverses for their coefficients. So this is 3d minus 2e equals negative 4. Needs to get solved with negative d plus 2e equaling also negative 4. Okay, it's a good day to solve a system by hand, I feel. I feel like I might have said that before. Okay, so this is going to be 2d, and this is equaling negative 8 if you add those up. So 2d equals negative 8, d is negative 4. See if that looks good. And this d can get plugged into probably either this or that slot to get e. I'll say 3d, so 3 times negative 4, negative 12, minus 2e equals negative 4. So negative 2e equals, what do you know, 8, and e also equals negative 4 in this case. And that gives you, sorry, that's a little hard to read, that gives you general form. And I'll put this up top here. We said it was y squared, that goes first, y squared plus dx, so minus 4x, plus ey minus 4y, plus f being 0 equals 0. And a quick move could get this into standard form, right? The y is staying on this side with a little space left to complete this square. The x is moving to the other side. And what do I want to add to both sides? Half of b squared, so just a 4 and a 4 factor. And GCF on this side. Kind of running through this quick, I apologize. And there's your standard form. Now we've answered the question, and we only have a minute left. Can we, shall we, should we? Should we go above and beyond and get the vertex, focus, directrix, axis of symmetry? I can hear you now saying, yes, we should do it. It's good practice. Vertex is sitting here for us, -1, 2. We're down to 40 seconds. Focus, well, p in this case is going to be 1 if 4p equals 4. And which way does this open? It opens in the positive sideways direction. Add 1 to the x. Make it 0, 2. I don't know why. I always do the axis of symmetry next. It's just a force of habit, the shared coordinate. They both have y equals 2. And to get it in before the buzzer, with 12 seconds to go, directrix is perpendicular to the axis of symmetry. We went 1 unit to the right to get to the focus. We got to go 1 unit to the left of the vertex to get to the directrix. So we're going to go down to -2. I think it is.